How's it going? Welcome to this episode, I guess, of testing an electric bilge pump. Let me show you what I got going on here. This is the test tub in action, and basically what I have is a 2,000 gallon per hour seaflo bilge pump, and I'm testing different impellers. So right now this is the stock impeller as it comes, and it's pumping through. There's a little pressure takeoff right here, which goes into this tube. I have a pressure gauge, but it's not quite sensitive enough. It's 0 to 30 psi, but it won't really measure 1 psi. So right now I've just got this tube up here, and that is the height of the water column right now. So I measure that with a tape measure in centimeters, and then I can convert that to psi. Basically, I have a nozzle on the end. I've got a whole series of nozzles here, and as the nozzles get smaller, the pressure goes up and the flow goes down. So as soon as I get to a nozzle that's small enough to generate some serious pressure, then I switch over to that gauge. I have a flow meter right here. Now, this number has been moving consistently, like I calibrate it by filling a bucket. So I basically time how long it takes to fill this bucket to 25 liters, and I'll use that as the volume. But I'm also getting a volume on this. It's not 2.3 liters per minute, but this is consistently moving. So by whatever that's off by, it's consistent at least. And you can see it sort of moves around a little bit, but what I do is I just stop and start it in time for a minute, and then I get the average up there at the end of a minute. And I'm running everything at 12.8 volts. That's knocked down to 12.79 right there. But for all the tests, I make sure that's at 12.8. So I'm also measuring the wattage. I predict that as I get to a really, really fine nozzle, I'm actually going to use less watts. And I've tested this by just sort of plugging this off against the bottom. The power use drops slightly because you're really not doing any work at that point. But yeah, this is the setup right here, and this is my little chart where I'm gathering all my data. So nozzle size, the flow readout on that gauge as opposed to the time to fill the bucket, so I can compare these and make sure everything's consistent. Pressure, I have the pressure in lift up that little vinyl tube, as well as the pressure on the PSI gauge right here, NA next to the PSI gauge, because I don't have quite enough pressure yet. And here's the wattage so far. So I'm going to fill up that chart. Basically, I just pop off one nozzle, pop the next one on. Everything in green is an even number in millimeters, so that's 12 millimeters. And I jumped by 2 millimeters each for the large sizes. And then when we get to the small stuff, I made every second one a different color so I don't mix up, because it's kind of hard to tell the size difference between that and that and that. So this is 1 millimeter, 2, 3, 4, 5, all the way up. And yeah, once I've done this, the purpose, I guess, of doing this is I should get a pump graph. So on one side you've got pressure, on the other side you've got volume, and it should be a curve. When you have all volume, no pressure, and then you change nozzle size slightly, it's not really going to affect your volume much, but you know, it's just going to be flat as it goes over, and then it's going to round over a little bit, and then the other end, for example, going from a 1 millimeter nozzle to a 2 millimeter nozzle, I'm going to get more than twice the flow with this nozzle than this nozzle, and I'll bet the pressure will be completely unaffected. So it's not going to change very quickly on this end or at that end, but somewhere in the middle, it's going to change rather quickly. And basically what I want to find is the area under the curve. I can probably show you that on the graph later, but I want to see how much work's being done by the pump, and then I can pick a nozzle size that is appropriate to a electric gold dredge. And what I want to test is I want to pick something on that curve that's slightly higher pressure, lower flow, versus something that's higher flow, lower pressure, but both doing the same amount of work according to the pump chart, which I'll show you. And then we can sort of see which one translates best into the actual gold dredge, but through data and science instead of just guessing. I've got a fair bit of work to do, so I'm going to populate this chart over here. Of course, the page has just moved in the wind, but yeah, we'll let you know how all this goes and show you the chart at the end of it. Just finished the 16 mil nozzle, moving on to the 14. There's definitely, you know, it's starting to get narrow. These were fairly lackluster up to this point, but we're starting to see some, you know, a real good jet of water. If it was in a high banker like this, it would work really well. And our numbers so far, we've gone from filling up that bucket. So that guy there, 25 liters worth, has been taking 17 seconds, just wide open, 17, still 17. These numbers are going to fluctuate a bit because, you know, user error. But to go from 17 seconds all the way up to 22 seconds, you still have a lot of flow. And we're just barely starting to get a reading on the PSI gauge. So this thing is no longer able to work. The water would go all the way to the top and start coming around, right around that, what nozzle size was that? Right around the 18 mil nozzle, which was this guy right here. I started getting just enough pressure. And this was the first one to make a reading on the PSI gauge. We're just barely coming off that 0 mark. So here we are. We're going to go 14, run it through the gamut. And at this point, when I bring it out of here to fill this up, you can feel there's a little bit of power coming, trying to splash water everywhere. So this would probably be the maximum nozzle size that you would ever actually want to use to, you know, create some real pressure in a dredge or a high banker. But I suspect we're going to wind up somewhere in around this area is where we're going to get the most power out of it. And then here it's just, you're restricting it too much. But that's why we're doing these tests and we're gathering the data so we can figure it out for sure. Okay. This is running a 14 millimeter nozzle, which is right between this 12 and that 16. And I just filled up this bucket. It's now taking about 24 seconds to fill the bucket. The flow reading is at 1.74, and watts is still right around that 110 mark at 2.8 volts. This is now registering some PSI. If you count, there's 10 notches between like 5 and 10, so each notch is half a PSI. And there's not 10 down to 0. So it actually, 0 isn't all the way to 0. So that's where I had to just do it with the height before. But we're registering PSI now, and it's actually looking good. So I'm just going to show you. Decent amount of flow coming out. Getting a bit dark here, but I just want to demonstrate something quite interesting. Notice we're down to about 87 watts there. I'm on the second lowest nozzle size, so a 2 mil nozzle. You can just barely even make out that there's a hole in the 1 mil. And I just finished doing the 3 mil. So you've got this little jet of water, but right there we're at 5 psi, and that hasn't changed for a while. So we could have 5 psi this size of a stream, or 5 psi this tiny little stream over here. We're clearly doing less work as a result. And to fill this bucket with the last one took over 6 minutes. So we're getting to that edge of the pump curve where it doesn't make any sense with this pump to run a nozzle this small. Now, if you have a pressure washer, you may notice that your pressure washer has a nozzle even smaller than that, and yet, you know, you're running 3,500 psi. Here we're running 5 psi. So based on the pump, there's going to be the most appropriate nozzle size. Most of the time with gold dredges, you're going to say, oh, a 2-inch dredge needs a 1/2-inch nozzle. In this case, I would use the most correct nozzle based on which one's doing the most work, not which size dredge I have. So you want to match to your pump first and to the dredge second. That's kind of what I'm hoping to learn more about by doing this. To have a quick look at my data so far, the flow meter stopped working at really low flows, but luckily I still had the bucket. I did not stand around for 1 hour and 40 minutes for the 1 mil nozzle to fill a 25 liter bucket. I just did the math after filling a single liter. Same with this one here. But yeah, it's really interesting. PSI peaks at about 5 psi right here with a 4 mil nozzle. And so it makes no sense ever to go any smaller of a nozzle than that. but really, I mean, we're at 4 psi over here with an 8 mil nozzle with significantly more work being done. Filling that bucket in just 1 minute, whereas with the 4 millimeter nozzle, it took 3.5 minutes to fill the bucket. So that's where you got to figure out which point is actually going to work best. And I'm going to have to go throw this on a graph now. Stock impeller there, 3 blades, open impeller. These are the same ones. I just printed this as a single piece. So the top is really nice and smooth, whereas this I printed in 2 pieces. So the underside of this is really nice and smooth where the water is going to be flowing. This impeller is now going up against this impeller. I should see 7 meters of head instead of 5 meters of head. We'll see how that translates to PSI. This hit 5 PSI as a peak. Well, see what we do with this. There you go. That impeller is in. Just finished testing for the night, and I can tell you that according to science, and you don't even need to look at this, but I have developed an impeller that is objectively worse in every way than the stock impeller. The win is that I've proven this with science. So I had lower peak pressure and more wattage to get it, as well as like across the board less flow at each nozzle size. So yeah, as far as designing impellers, I have stuff to learn. But what's awesome is that with this particular impeller, I know that it doesn't, like, it's not worth using it. And even if I could only ever pick, you know, the stock impeller or the crappier one that I built, at least I know which nozzle size will work best in the stock impeller. But I am dead set on finding a better impeller. So time to play with the designs and get to work. Got a test station. I can get these pump charts out. I'll show you a graph of the stock one so you can kind of see how it all stacks up. But yeah, if I didn't do this scientifically, I might think, ooh, my pump must be better, and I would be doing myself a disservice. But there you go. I've created a worse pump. There's your evidence. Let's just have a quick peek at, say, a nozzle size of 10. I was at 2 psi. Or actually, let's look at a nozzle size of 8. So filled the bucket in 1 minute and 5 seconds, 3 psi, burning 119 watts. As we go over to here at 8, I was burning only 96 watts. I was up to 4 psi, and I filled the bucket in 59 seconds, or pretty much 1 minute flat. So took 5 extra seconds to fill the bucket, 1 psi less, and more power with my impeller. So there you go. Live and learn. Okay, one final one to test. I just determined that the gap I have between this impeller and this housing is about 1.5 mil, so I can actually bring this out an additional millimeter for the next one. The tighter that clearance, the less sort of recirculating of water you would have, and it would be slightly more efficient. But at this point, I'm just concerned if this is even going to work. So here's the new impeller. Got some splitter blades in there, so it's 4 main blades, 4 splitter blades, a little bit of a different design. Let's hook this right up to an 8 mil nozzle and see how it does. Good news and bad news. The stock seaflo impeller, I think, still wins by just a hair, but it was using more power at this point. So I'm using roughly 85 watts right now with the 8 mil nozzle. With the stock impeller, I was using 96 watts. So that's a significant power savings here, which means obviously I can print a slightly larger impeller to get my numbers up. But with the 8 mil nozzle, it was 0.71 on the flow gauge, and I just did a reading at 0.68. So very similar in flow. And before I was at 4 psi, here I'm at a healthy 3.5 psi. So I'm very close to the same numbers, a little bit lower, but also a little bit lower on power consumption. The good news really is that the last time I 3D printed an impeller, there were some mistakes in that. So there, with the same 8 mil nozzle, I had 0.72 liters per second, or it's not actually liters per second, but it's what this gauge says. This is 0.72. 3 psi, so lower psi, and I was burning 119 watts to do that. So this is a major improvement over that last one. Impeller 13 is coming off, and we're going to be replacing that with impeller 14. Very slightly larger diameter, so I'm aiming for a higher head pressure, and it's slightly narrower from the side view, so we should have a lower flow rate in order to maintain the same wattage. So here it is, impeller number 14. Let's hope we actually have some success with this guy. Basically just put that snap ring on and then rebuild everything all together. So I'm explaining to you and Carol here what all my numbers mean. Are you excited about these?
Yes.
Carol's very excited. Basically the stock seaflo impeller, so like this 2,000 gallon per hour pump, I tested all of these different nozzle sizes, and at each nozzle size I determined how much flow there was as well as how many psi of pressure there is. So the idea being that if I multiply the flow rate by the pressure, that's sort of the amount of work that's being done by the pump. If we have a very small nozzle, that's where I get the maximum pressure. So with the stock seaflo pump, I peaked at about 5.2 psi with a 1 mil nozzle, 5 psi with a 3 mil nozzle, and I basically at a 4 mil nozzle, I still had 5 psi. That's sort of where it pinned the pressure. So if the pressure is the same, it makes sense that you'd go with whichever one of these has the most flow rate, and that's the most actual work being done. And through that logic, at the other end of the chart, it also doesn't really make any sense to just run it wide open because you have no pressure. So what I found was by multiplying the flow by the watts, my best number, which is a 381 in this case, I don't know what unit that's in, but 381 would be better than 380. That was, I managed to get 3 psi, and that was at an 11 millimeter nozzle. So a half inch would be 12.7 millimeters. So you want to go just under a half inch, probably a 7/16 inch would give you the closest to that 11 mil. And now Carol, who's very excited about all of these numbers, would know that with the stock pump, don't worry about half inch nozzle for 2-inch dredge. With this pump, you're going to get the most work with an 11 millimeter nozzle. And that number again was 381. So if I flip ahead to impeller number 14, very exciting. Impeller number 14, and I will have to do this on a graph in a future video that has some better, so you can see what's going on. But that 381 number in this case is 556. That's where I peaked. Unfortunately, that 556 also happened to use 29% more power, just sizing the pump rate, so I was using more amps and energy to get there, but that 29% more power gave me 46% more actual water coming out. So we're more efficient, and I've been able to sort of get more output, and with my pump, it turns out a 9 millimeter nozzle is the most efficient. So the stock seaflo, it's aiming for a little bit lower pressure, and so it would make sense that you need a larger nozzle to take advantage of that. My pump, I was aiming for a little bit of a higher pressure, and so I need a slightly smaller nozzle to take full advantage of that. So I'm down to a 9 mil nozzle versus that 11. And just to finish off the video real quick, I'm going to fire this thing up to about 12.8 volts, and you can see the 9 mil nozzle running. It's putting out a lot of power. I have a lot of work to do refining this before I get into building a dredge, which, by the way, is why I have this. This is set up to test with this 1-inch hose here, and it's essentially just so that I can sort of put nozzles on it and see how much flow is happening. If I were to set up a 2-inch dredge, I need something that has sort of a 2-inch dredge outflow, and I'll be able to see the actual volume traveling through the dredge based on different nozzles, as well as, twin jet, triple jet, infinity jet, all the things I want to test once I dial in these pumps. So here we are, 9 mil.
I had some cavitation there. So there was some air in the pump. That makes more sense. There you go. So this is running 5.5 PSI right here, which is the peak PSI I had when I completely deadheaded the stock pump. But through a 9mm nozzle. So there's a lot of work being done. I'm happy with that. But yeah, in case, I don't know. That's basically all I got for you. I'm running a little late on my video production. I know I like to get these out at least a few days ahead of time for my Patreon members. I'm trying to make that at least a week ahead of time. So if this video is a little bit late, I do apologize, but there's a lot of learning to be done here. And as soon as I get all this information together for those fellow nerds out there who really, really want to know everything there is to know about bilge pumps and impellers and gold dredges and jets, hopefully this will be the place you can come to scratch your little itch for information. Till next time, cheers everybody.
He's not locating. He's looking.